Hello everyone, this is day 17 from Advent of Code 2024. This is another one where I couldn't record because I was on a trip, so now I am making it up. So this one is all about virtual machines, which if you know Advent of Code, virtual machine problems are very common. And so we need to essentially simulate this virtual machine through the specs it gives, running all the instructions, through the registers and stuff like that. And then this one involves an output array that we have to export out in using the A register given in. And so that's pretty simple. All we got to do is create all the instructions and run it like a normal virtual machine, and then see if they're, what the output is. And so that's honestly pretty simple, but part two is where it gets very complicated. And so part two, we have to figure out what value of A, what's the minimum value of A that will give the output back. And so this is where I'm actually going to explain the specs of it a little bit. Essentially, this is a 3-bit machine where the registers, there's 3 registers, each of the instructions and each of the opcodes are 3 bits. And then it has, technically it isn't 3-bit because it deals with numbers that are greater than 3 bits, but everything around the program, including what the program does itself, is 3 bits. And so here's the program deobfuscated or decompiled. If you go through the instructions, the ADV, the BDV, and the CDV are just bit shifts. Which it's a bit different, but they're essentially just bit shifts, so you can just sub those in. And then, like I said, I decompiled it to get to this. And so this is me running some tests. And then what I realize is that we're only dealing with 3 bits at a time. As you can see, we're ANDing it with 7, and we're outputting 3 bits at a time. So that means that every octal digit that the A has, so I don't know how many octal digits this has. I think, given my input, it has 9. So this has 9 octal digits. That means it's going to output 9. So here we have 5, we have 10, we have 16 digits, which means it's going to be a 48-bit number. And so one complication is that TypeScript / JavaScript, whatever, they cannot do bit operations on 48-bit numbers. The max they can do is 32-bit. So we have to switch to BigInt to allow for that to happen. But that's the only complication. So to figure out the smallest A, we can use a recursive function that essentially tries every possible value. And so because we can skip through, as soon as we find something that works, we can just keep skipping through it until we find the next number. And to do that, we use this +8n. Because we're dealing with octal digits, to get to the next digit, we need to add 8 to it. And with these bit shifts, that means that we use 8 to the I iterations. So essentially, that's why we have to use the BigInt as well, is because the numbers do get quite large really quickly because of our exponential growth for iterations. And so so then we can just use this recursive function to find the smallest A, and then I think the smallest A was this big number here, and that doesn't take too long. It took less than a millisecond for part A, and then 1.5 for the second part. And so if you want a bit more explanation, I wrote it down here, but other than that, that is what I did for part 17.